Logic microoperation. Logic. Okay. So how it is going to be called as the logic microoperation, and what are the various operations that we are going to perform here? Okay, that we are going to see inside this. So already you know about logic gates. What are the logic gates? Okay, what are the logic gates? You can write in the comment. AND gate, OR gate, XOR, inverter, all these things. And most popular universal gates are NAND and NOR gates. Okay. What are the universal gates? NAND and NOR gates. Since all other gates we are able to design with the help of NAND and NOR gates. Okay. So let's start with logic microoperation. So before this, we have already previous topics are there. Okay, you can watch there. And still you didn't subscribe, subscribe the channel so that you have a regular notification you can get about the new update. Okay. So I welcome you all in this lecture of the logic microoperation. So now here, this logic microoperation is going to perform the bitwise manipulation. Is going to perform the bitwise operation. Okay. So it is applicable on the string of bits. String of bits, on that you are going to apply this. So this string of bits are stored where? In the register. So whenever processor is going to work, so this processor is going to take the help of the registers. So those registers we are going to represent by the capital letter R and float by the decimal numbers. R1, R2, like this, R3, like this we are able to write. And before that already we have seen, if you are going to talk with memory, so you have MAR or AR, all discussion is separate. Okay. So now here this logic operation is useful for the bit manipulation on the binary data. So with the help of this logic microoperation, we'll able to perform the 16 microoperation. Okay, so this is just like a small diagram here. Later we have big table for this, where you can see that we have all different 15 micro operations. So that is 16 micro operations. Okay, so this one is the F15. Okay, this is looking like a 16, but this is the F15. So total 16 micro operations are there. So that we are going to see here. So now suppose, so already we have seen earlier, this is what is the role of P. So P is going to act as the control. If P is the active, if P value is 1, then only whatever instruction is given, that micro operation takes place. So here you have symbol of XOR gate. So this is going to perform the XOR operation between the contents of two registers. So now here, for example, it is taking that R1 having 4 bits, R2 also having 4 bits. So it performs the XOR gates operation, and XOR truth table you need to keep in mind. Okay. So what is XOR truth table? When we have both inputs are different, then output is high. So 0, 0, output is what? 0. 0, 1, output is 1. 1, 0, output is 1. 1, 1, output is 0. Okay. So here all possible combinations are here. 0, 0, output is 0. 1, 0, output is 1. 0, 1, output is 1. 1, 1, output is 0. So this is going to perform the XOR operation if P is 1. If P is 0, even contents of R1 and R2 is available, it will not perform this XOR operation. So that P is used here as the control, okay, with column symbol. So now this list of logic microoperation with the help of two binary variables. So if you have n binary variables, then we'll have how many functions are possible. So that number of functions will be 2 to the exponent 2 to the exponent n. Okay, so that much functions will be available. Here we have, okay. So now finally here n is 2. So what we'll get here? 2 exponent 2 exponent 2. So what will have 2 exponent 4? So 2 exponent 4 is what? 16. Okay. Since we are using the binary numbers, we have only 2 variables. So that's why this 16 functions are possible. If somewhere we have n variables, binary variables. Okay. Here we have taken only 2 inputs, A and B. Okay. On the basis of that, 16 combinations are possible. If you take here 3 like ABC, then with the help of 3 bits, we'll have how many combinations? So that will become to the power 2 exponent 3. Okay. So here exponent to the power exponent is being multiplied. So what will happen here? We'll have to the power 6. So to the power 6 will come how much? That is going to be how much? 64. So that 64 functions will be possible. Okay. So here simplest example is taken where we have 2 bits only. Okay. Only 2 variables are here. So we have 16 logic micro operation here. So first one, it is going to be f naught value is going to be 0. So whatever is contents is here, that contents is going to be clear. So like here, if you see that F0 is perform the clear operation. So whatever contents of A and B is there, that is being cleared here. Next is the F1. This is what? XY. XY is what? So here, this symbol for the AND operation, is taken like this. So A, okay, you can resemble with A without that horizontal line, and for the OR operation it is taken as the opposite of this, that is the V, and this for the AND it is the inverted V, and for the OR it is the V. So now generally for the OR operation what we use symbol A plus B, but here for the arithmetic addition also we are using A plus B. So that system will have confusion whether it is the arithmetic addition or it is the logic micro operation. So that overcome of this confusion, for the AND gate we have inverted V, and for the OR logic operation we have V. Okay, this is the symbol what is being used here. So this XY perform the AND operation. So here this F1 is going to give us the AND operation. So 0, 0 AND gate, you know that if all inputs are high, then only output is high. So 0, 0 output 0, 0, 1 output 0, 1, 0 output 0, 1, 1 output 1. So that we are getting here. Similarly, F2 is going to perform the AND operation of A with B complement. And F3, same contents of the A is being transferred. Okay. So on F4, you have AND operation with A complement, and B. F5, again contents of B is transferred, and F6 going to perform the XOR operation. That example we have taken here. So that is the function F6. So it is going to perform exclusive OR between two register contents. F7, again it is going to perform the, here for the our understanding we have written plus X plus Y is going to perform the OR operation. X plus Y dash. So F8 is going to perform the complement of OR, that is the NOR operation. Okay, so NOR gate operation. Again here X XOR dash going to perform the X NOR, exclusive NOR. Y dash is the complement. So F10 performs the complement. F11 X plus Y dash. So it's going to perform the OR operation with contents of A and complement of register B. F12 is the X dash complement. Here again we have F13, that is going to perform the OR operation between complement of A and B. And F14 XY dash is going to perform the AND operation between A and B and their complement. So finally it is what? NAND gate. And F15 all is the 1. So like here, you see that F15 all is 1. F14 is the AND gate. So AND gate is F14 is the NAND gate, not AND gate, NAND gates. So NAND gate output is opposite to the AND gate. So this F1, F14 you can compare. NAND gate means if any input is high, output will be high. Okay, NAND gates. So in general, if any input is low, better you can use the word. In case of NAND gate, if any input is low, output will be high. Okay. Whereas in case of AND gate, if all inputs are high, then output is high. Okay. So like this, we have 16 functions when we have two variables here. So those 16 functions here you can see in detail. Okay. And you can verify this table to pause the video and this lecture and you can verify the tables. As per the previous table, corresponding functions are performed here in the well manner or not. That is going to satisfy the all 16 functions or not. Now here is the example why we are not using the plus sign that already I have discussed. Same thing is written here. Like here P plus Q. So this P plus Q with column is the control signal. Okay, this is the control part. Now operation is what? R2 plus R3 is transferred to R1. And here, so now in this case, what we are seeing that this between R2 plus R3, it is what? Arithmetic addition operation. And between R5 and R6, it is the logic OR operation. And their contents are transferred to the R4. Okay. So confusion should not come. That's why for the OR, we are not using the plus. We are using the V. And for the AND operation, we are using the inverted B. So these are the discussion how again those logic microoperation, if it is not visible there clearly, okay, for that separate table is provided here. Now how we are going to implement those logic microoperation in the hardware. So if you try to implement those 16 logic microoperations separately, so for that hardware requirement will be more, so that system cost is going to increase. And even if you have two variables, we have 16 functions. If you have three variables, we have seen that we have 64 functions. So like this, if input variables are going to change, so that finally number of functions are going to change, okay, by this expression. To overcome of this, that system is going to use, or in the hardware, only 4 gates are implemented. This is the AND gate. This one is the OR gate. This is the XOR gate. And finally, this is the inverter. So by the help of these 4 gates only, all other logic functions should be realized. Okay. So since 4 logic gates are used, so the multiplexer size is 4 cross 1. So this 4 cross 1 is written as 2 to the power 2 cross 1. So number of selection line is what? 2. So that is the S0 and S1. So this AI represent the corresponding bits of that registers, or you can say that ith bit of that register R1, or any name, what name you are going to utilize. And BI represent the ith bit of the another register. So finally, this logic circuits with n bits, okay, then this diagram must be repeated n times. So that will start from the 0, 1, 2, and for the n times means it will go to n minus 1. So how many bits are there? As per that, we are going to repeat the diagram. Okay. But only 4 logic gates will be used. Okay. A repetition of the diagram is okay. But new hardware we are not going to design for the another logic operation. So now in this situation, what we are seeing, selection line, if you have this connection, you see that output of AND gate is connected to port 0, OR gate is port 1. XOR port 2 and inverter to the port 3. So this inverter means complement. So when selection line is 0, 0, so this output is what? To perform the which operation here is going to perform the AND operation. So finally here we have AI, okay, and how we are writing? Inverted. So AI, BI. Similarly, OR gate. So this operation is AI, BI. XOR, AI, XOR, BI. And complement, whatever information is there, that will be complemented. So AI bar. So that you can see, observe in this table how this is going to be functioned. Now, what are the various applications of this logic micro operations? How it is going to be useful for us when we perform which type of this logic operation, like we have seen only 4 we are going to use, that is the AND, OR, XOR and complement. How it is going to helpful? What is the use of this? So this logic micro operation can be used to manipulate the individual bits. Already this logic micro operation is the bit-wise manipulation. So that individual bits of the contents of that register will be handled here. So consider that data in register A and another register is considered as the B. So now how contents of the A will be modified. So for that, first one, what we have? Selective set. So we are going to see one by one. So here hint is given that is going to perform the logic OR operation with A and B, and that contents will be stored in the A. In case of selective complement, XOR operation between A and B is performed and contents will be stored in the A. Next, in case of selective clear, which operation is performed here? AND operation is being performed between A and complement of B and is stored in the A. Mask, that is the delete. So in that case, AND operation is performed and contents is stored in the A. Clear, again XOR. Insert, when we are going to insert some information. So there first AND operation will be performed, then OR operation will be performed. When we are going to compare, there also XOR operation will be performed. That all these applications now we are going to see one by one. Any doubt is there, you can write in the comments, okay? If you have any other requirements, that particular topic also you can write. So in case of selective set, name is what? Selective set. So particular bit is being selected in the contents of the register A. Okay. So now how that bit is being selected? On the basis of the value of the contents of the register B. Now what is the logic here? Whenever contents of the register B is 1. Okay. Whenever contents of register B is 1, then corresponding bit of the register A is going to be what? This value is going to be set to 1. Okay. So like here you are seeing that B is 1 and contents of the register A corresponding bit is what here? 0. So finally that 0 is changed to 1. Now here again MSB bit of B is 1, corresponding bit of A is 1. So it is already 1. So it's remained 1, 1. So in case of selective set, the corresponding bit of the register A will change to 1 if corresponding bit of B is what? 1. Or in the another way also you can say that if contents of or particular bit of the B is 1, then corresponding bit of the register A will change to 1. If it is 1, it will remain in the 1. Okay. So, and when B value is 0, that contents of A will remain same. What was the previous value that is written here in the word. In case of, so here which operation is performed? Logic OR. You can see here 0 OR operation 0, 0, both inputs are 0, 0. So OR gate, okay, 0, 1, 1, 1, 0, 1, 1, 1, 1. So OR gate means if any input is high, output is 1, otherwise output is 0. That is the output is low. In case of selective complement, so part name is the selective. So that particular bit of the register A, we are going to select by the contents of the register B. Okay. On the basis of that, this performance will take place. So in case of selective complement, whenever contents of the register B is 1, whenever bit of the register B is 1, then corresponding bit of the register A will change to 1. That is the complement. If it is 0, it will become 1. If it is 1, it will become 0. So here you see that B is 1, A is 0. So it changed to 1. When B is 0, no change in the A bits. Now again B is 1 here. Then and A is what? A. So this A will change to 0. So now here XOR operation is performed. 0, 0, output is 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. So whenever contents or whenever bit of the register B is 1, then corresponding bit of the register A will be complemented. It is 0, it will become 1. It is 1, it will become the 0. If B contents of B is 0, then corresponding bit will not change. Like here, B is 0, A is 0, remains same. Okay. So that again here B is 0. So that corresponding bit of A will not change. So A is 1, that remain as the 1. Now is the selective clear. So clear, that bits is going to clear means going to be 0. So now again, what is happening here? What we are going to see? If it is already 0, that will be as the clear one. Okay. So finally, you see that in case of selective clear, whenever contents of the or whenever bit of the register B is 1, then corresponding bit of the register A will change to 0. Now here B is 1. Okay, corresponding bit of A is 0. So already 0, so remain 0. Now here B is 1 and corresponding bit of A is what? 1. So it must be changed to 0. Okay. So corresponding bits change to 0. Whereas in complement, corresponding bit used to change to complemented. If it is 0, it was happening 1. It was 1, it was happening 0. But here, corresponding bit, whatever value is there, that value should be 0. If it is 0, well and good. Otherwise, we will change to 0. So here, this operation is same as we are performing the AND operation of the contents of A with complement of B. Okay. So that you can verify here. And whenever bit of B is 0, then value of A will not change. B is 0 here, A is 0, remain 1. B is 0 here, A is 1, remain the same. Okay. So you have to see that name properly. Next is the mask operation. So mask, like in the COVID time, people are applying the mask, right? So when we are trying to do some operation, so this is especially if you talk about the electronics, when we go for the fabrication, when we try to make the diode, when we try to make the transistor, there we are talking about the masking, etching, all these things. So here, what is the concept of the mask that we are going to see? Mask means generally protection, okay? So now here, in case of mask operation, again, that bit pattern in B is used to clear the contents of the bit in A. Now, particular bit only where you want to change, that we'll understand again more later when we'll see the insert operation. So now here what is happening? Logic and operation is being performed between the contents of A and B. Okay. So what we are seeing here, if you'll observe here, LSB bit is what? 0, 0. Here output is 0, 0, 1. AND gate output is 0, 1, 0, 0, 1, 1, 1. So what is happening here? If a bit and B is set to 0, then same position in A is get set to 0. So earlier we are considering the 1. Okay, sorry. Earlier we are considering the if bit of B is 1. Now we are going to focus if contents of B is 0. So now here, like here, B is 0. Okay. Then same position is A is also set to be 0. So it's already 0, so become 0, no problem. Now here B is 0. So same corresponding position of A is 1. So now this A is set to be 0. Remaining position, whenever bit is 1, that will be unchanged in the A. So here is logic end. Next we have clear operation. So in clear operation, if bits in the same position in A and B are same, then they are cleared. So if they have same bits values in the same position, then it will be clear, otherwise it will remain same. Like here, both are 0, 0, no problem. So already clear means again 0. Here MSB both are 1, clear means it becomes 0. But here you see that both are different bits, 0, 1, 1, 0. So this value remain what? 1, 1. It's not cleared. So that's why here, which operation? XOR 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. So what is the logic here? If both having same bits in same position, then it will be cleared, means it will become 0. Otherwise, it will be 1. Next, we have insert operation. That is very important. Okay. So many applications are there for this. So in case of insert operation, so we are going to introduce the specific bit in the register A in particular position. So only that bit position will be affected, remaining bit position will be unchanged. That bit value will remain same. So for that, two steps is required. First one is the mask operation to clear the desired bit position. Then we have followed by the OR operation to produce the new bit, to introduce the new bit in the register A where you want to introduce. So for that, here example is taken, contents of the register A is 0, 1, 1, 0, 1, 0, 1, 0. And we want that for leftmost bit. So this leftmost bit here is 0, 1, 1, 0. Should be replaced by the value 1, 0, 0, 1. So in place of 0, 1, 1, 0, we want to introduce 1, 0, 0, 1. So first we need to do the masking. So which value 0, 1, 0, 0, 1, 1, 0 you want to change here, okay? So here mask B is used here. So which bit you are not going to change, for that corresponding bit of B is 1. Which bit we are going to change? Corresponding bit is the 0. So when corresponding bit of B is 0 and then corresponding bit of A will be going to become 0. So finally here, again we have AND micro operation is performed here, logic operation. So 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1. So AND gate here 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0. So here we have to choose the mask properly. Okay, which bit you want to change, then corresponding bit of B will be 0. Otherwise, the remaining bit of the B will be 1. So now masking over. So now contents of A become this. Okay. Now which bit you want to insert? So that should be in that particular position and remaining bit of the B should be 0. So now already masking is done. So below that bits only will be the new bits what we are going to introduce. So finally now we have kept here 1, 0, 0, 1 for leftmost bit and for rightmost bit as the 0. And here our operation is performed 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1. Similarly here 0, 1, 1, 0, 0, 0, 0, 0, 0, 0, 1, 1. So first masking in which AND logic micro operation, insertion or logic micro operation. So these are the things what we have in case of logic micro operation. Okay. So any doubt is there, you can write in the comments. Okay. And like, subscribe our channel. Okay. Thank you. Thank you very much.